In this lesson, we're going to take a look at creatinine. So creatinine, like BUN, is an indicator of how well our patient's kidney is functioning. So the normal value for creatinine is 0.7 to 1.4 milligrams per deciliter. So how does it work? So let's get into that. So as we use our muscles, there is this breakdown of all these waste products. So you have this in the energy cascade of muscle use, you have this thing called phosphocreatine, or PCR is what they call it. Well, what happens is this phosphocreatine, as a process of muscle breakdown, is actually converted to creatinine. And then what happens is it's sent into the bloodstream, where it is excreted and picked up by the kidneys and kicked out to urine. So you've got PCR converted to CR, which is creatine, sent to the bloodstream, sent to the kidneys, out into the urine, via the bladder, and it's excreted. The difference between things like BUN and creatinine is that the creatinine is more specific to the kidneys, meaning that it's less influenced by diet and also hydration levels. So when we're looking at creatinine, we're looking at specific kidney function. So just like the BUN, you're going to submit it in a green top tube with your chemistries. You'll also see it in your Chem 7 or your Chem 10. You'll also see it in your renal panels. You'll also see it in maybe your basic metabolic panel, which is also known as a Chem 7. Just depends on what your facility has. And also your comprehensive metabolic panel. You'll also evaluate your patient's kidney function there. There's also another test that you'll see called creatinine clearance. And what it does is it tests creatinine in the urine and it compares it to the serum creatinine. So you got your creatinine in your serum and then you got your creatinine in your urine. And what they do is they compare the two, and they want to make sure that you're not having a buildup and that the kidneys are working. The thing that you have to remember is there are three things you need to remember. First, it's a 24-hour urine collection. So you're going to have your little container that you put your orange jug in. It's your orange jug, and you're going to take your patient's going to void, and then you're going to collect them. So that's your first thing you have to remember, is a 24-hour urine. The second is you're going to put it on ice, because it's not like you can just collect it and put it in a refrigerator. So you'll have like a little container, you put your ice cubes, and you'll put your little orange jug in it. Now, this is the last part, and this is the most important part. Your patient's going to void, and you're going to discard the first urine sample. And then you're going to collect every sample thereafter for the next 24 hours. So again, 24-hour urine, you can put it on ice, and you're going to allow your patient to void and then start collecting your patient's urine for the next 24 hours. You need to do a couple things, but first is to make sure that what your facility policy is. You need to make sure that you're following the facility policy when you're talking about your 24-hour urine, but always remember to discard that first urine. So let's take a look at some abnormal creatinine values and what it means. Well, the first thing, if you have an elevated creatinine, is that you probably have some sort of renal disease. The goal with any renal disease is to find out the cause first, and then of the kidney dysfunction, and then treat that cause. So if you have like hypertension or some sort of toxicity, you need to treat those things first, because if you don't, you're going to cause further kidney damage. You'll also see it in patients that have congestive heart failure, the elevated creatinine. You'll see it in patients with congestive heart failure. You'll also see it in patients with shock. Also, mild cases of dehydration, you may see it occasionally there. The other time you'll see it is in this case called in a condition called rhabdomyolysis. And what happens is there's some sort of trauma or some sort of muscle breakdown. So extreme athletes will have this, but myoglobin is released into the bloodstream, and myoglobin in large quantities are toxic to the kidneys. So what happens is you have this increase in myoglobin, and you're going to cause damage to the kidneys, and you're going to get this elevated creatinine. The times you're going to see decreased levels of creatinine are in cases of loss of muscle mass or muscular dystrophy. So remember that the muscles are where the phosphocreatine is converted to creatinine. So if you have lower levels of the phosphocreatine, you're going to have lower levels of the creatinine production as a byproduct of the waste. If you also have decreased protein intake through nutrition, in cases of liver disease and also pregnancy, you may see decreased levels of creatinine. We're talking about our nursing concepts for creatinine. We're looking at our lab values and also about elimination because we're looking at the kidneys. So let's recap. Our normal values for creatinine are going to be 0.7 to 1.4 milligrams per deciliter. They are an evaluator of the kidneys, because the kidneys filter out the creatinine. The times you're going to have increased creatinine are going to be if you have a kidney problem or a muscle problem, so things like rhabdo, and that's because you have that increase in the myoglobin production, which is toxic to the kidneys. It's going to cause those kidney values to bump. You're going to see decreased values of creatinine in cases of muscle mass wasting or loss, or if they have decreased protein intake. It is a specific kidney function value that's essential to those renal values. So if you're evaluating kidney function, make sure that you've got a creatinine on those labs. That's it for this lesson on creatinine. Make sure you check out all the resources attached to this lesson. Now go out and be your best selves today. And as always, happy nursing.